My name is David Andersson. I work at Canonical. If you don't know what Canonical is, we make Ubuntu. What I'm going to be talking about is how to sort of deploy your web applications. We're going to take Flask as the example on Kubernetes. So a simpler version of this title is, I want to deploy my Flask application. What are my options? So this is going to be the agenda. So I'm going to give you a quick introduction on the topic, show you the application. Then I'm going to also show you how to sort of turn that Flask application into a Kubernetes container. And then we'll take that, a Docker container. And then we will take that container and look at a few options for deploying that on Kubernetes. Okay, so let's say you have a Flask application or a Django application or a fast API application, that sort of stuff. And you want to run it in production on Kubernetes. So what are your options? Well, you have a few options. And I've listed kind of some sample options here from a variety, right? So you can either do it all yourself, which is writing the Kubernetes resources, so things like deployment services, that sort of stuff. And typically that's done using Helm charts. Then you can use a platform as a service tool like fly.io, which is very easy but proprietary. And then I'm going to show you something that Canonical and I've been working on using open source tooling, which also makes operations very simple, similar to fly.io. Okay, so let's say that you have this Flask application, a very simple one. It doesn't mean that what I'm going to show you doesn't work for more complicated applications. It's just that I want to show you how to deploy it. And so I want to keep the Flask application simple. We'll make it a bit more complicated towards the end by including a database, but for now, this is what it is. The other thing I just want to say is, if you don't know what a container is, it's basically a sort of packaged version of your application together with its dependencies, that sort of stuff, and then you can use that to run it anywhere where a container can run. And it's sort of standardized using the Open Container Initiative, which is a Linux Foundation project, has a specification around containers and things like Docker, Podman, Builder, Scopio, and some of the tooling that we're building is all compatible with that. Okay, so let's say that you want to create a Flask application, or you have a Flask application and you want to create a Docker image. So if you go on Google, do a quick search, this is probably what you'll find. So we start with 3.12, maybe we should start with 3.13 now, and then it just copies the requirements of text file, does a pip install, copies everything from your local directory, and then uses the Flask development server to run the application. There are a few problems here that we're going to address using some tooling that Canonical has created. So one of the problems is that it copies everything. So that might include things like your virtual environment, your Git, might include sensitive files on disk that you don't want in the container. And then the other issue is that it's using the Flask development server, which is not scalable and it's not secure. So it's not what you should run in production. So here's an alternative. Canonical has been working on a tool called Rockcraft, and it is a tool that you can use to create OCI images. And it actually natively understands Flask, so it knows how to create images for Flask applications. In the top right there, you can see a QR code, which is a link to a tutorial that will go through how to go from a Flask application all the way to a OCI image, which is production ready. And here you can see kind of a very high-level view of what the commands would be to create that OCI image. And what I'm going to do is I'm going to step you through what that looks like in a recording. So if you take a look here, we have in requirements of text file, we just have Flask, and then in the app.py file, we have the Flask application that I was showing you earlier. And just to demonstrate that it works, we would sort of use the Flask run command, and then if we send a curl request to localhost, we see that it's working as expected. It's just returning hello world, which is what the root endpoint is doing. Okay, so we stop that. And then I'm just going to show that the Rockcraft version 1.5.3 is installed. And then the way that we create a rockcraft.yaml file, which is the equivalent of a Docker file. The difference between a rockcraft and a Docker file is that in Docker you run a bunch of commands and then you take a snapshot at the end, and that's your container. In the rockcraft file, you kind of declare all the things that you want in it, what kind of debs, what kind of files, and so on, and then the tool called rockcraft will sort of package that all up for you. Okay, so and the command here just created a rockcraft.yaml file, so the equivalent of a Docker file that's designed to get your Flask application working in production. Okay, and here we can see what it is. It's got a lot of commented things in it to kind of show you how to customize it depending on the application, but by default at the top it just has a bunch of metadata, and then it uses something called an extension, which is how where we have coded everything for Flask. And then we can pack the Flask application, and at the end of that we get a .rock file, which is an OCI archive. And just to demonstrate to you that it works well with Docker, we're going to use the tool called Scopio to upload that into the local Docker registry and then run it. So that's what this command is doing here. It's just copying the OCI archive into Docker. And then when we run the Docker images command, we actually see that the image is right there. And then we can run it using Docker. And then we can send a curl request to the application, and then it's still returning hello world as it has done before. So if that was a bit too quick for you, again, the QR code at the top right takes you through a tutorial where you start with just a plain Ubuntu image, and then you do everything, including writing a little Flask application that in the end will have you running the Docker container in Docker. Okay, so now that we have the Docker application, the Docker container, now we want to deploy it on Kubernetes. So we're going to look at a few options. The first one is using Helm charts. So if you're not familiar with Helm charts, they are basically a templated version of the sort of Kubernetes resources that you might be more familiar with. So things like deployments, services, ingress definitions, and so on. So I'm going to show you how to go, again, from not really having anything to do with Helm to actually an application running on Kubernetes using Helm. So let's get going. And the Kubernetes cluster that I'm using is a sort of local development cluster that Canonical provides as well. It's called microK8s, so you can snap install that. And that's all you have to do. I was impressed by it when I first used it. Okay, so we just create a namespace here. We enable ingress because we want to expose the application so we don't have to kind of curl the container directly. And then we have to upload the OCI image to the microK8s registry because obviously it was previously only uploaded to Docker. So the microK8s registry needs it so that it can run it. And then we're going to take a look at the chart directory where I've defined everything that we need for Helm charts. So if we look at the chart.yaml, it's just a bit of metadata, including the API version, the name, that it's an application, and the application version as well as the chart version here. And then, just for simplicity, I've also created a values.yaml file which defines some common sort of pieces of configuration so that we want 3 replicas and what image we want to pull. And then now we're going to look at the deployment, the service, and the ingress file, which are templated versions of the standard Kubernetes deployments that you're used to. So if you take a look at the top, there's a little bit of metadata there, and then there's a spec for the deployment. And you can see in sort of the kind of curly braces, which is the standard sort of templating language, where we have pulled values either from the values file that I showed before or the chart file that I was also showing you before. So it's just a container with the name that we picked in the chart, and that deploys the image that we pulled, that we uploaded to the microK8s registry. Okay, and here we can see the service file. So at the top again, we have a bit of metadata, and then we have the spec, which just says what port it should be running on, and which deployment to select, which again is based on templated values, just so that you don't make any typos, and then have to debug that deployment. And then we can also take a look at the ingress, which, if you're not familiar with Kubernetes, is the way to take a service and expose it outside of the cluster. So again, top, we have some metadata, and then for the spec, we're saying that the application runs on a root endpoint, that we use the host name based on the name of the chart, and then it also selects the service. Okay, so those are the resources that we need, and then we can just use the Helm sort of extension for microcades to run the application, which happened very quickly. And then if we send a curl request to the local host, then we will see that the application is working as expected. Here we had to put the host there because that's how the ingress routing is working. Okay, so that's the Helm chart. Using Helm charts, you get a lot of control over how your application is running, but you also have to do it all yourself. And let's say in this example, it wasn't that complicated. You just had the Flask application, and it still took us quite a few minutes to actually go through and show you what the resources were defined as. And you can imagine that if you have more things in there, like a database or maybe Redis and that sort of stuff, then it gets more complicated very quickly. So let's say you don't want all the complications. What can you do? Well, then there are services like fly.io that will run your Flask application as a sort of platform as a service type of offering. So let's take a look at how that works. So the first thing is that we just need to install some command line utilities to interact with the fly.io service. And then we need to configure it a little bit. Okay, and now we are ready to run the fly launch command, which is kind of an initialization command, which will first you have to log in, and then it will write some configuration files that are required to sort of run your application on fly.io. So here we're actually going to deploy it in Spain and using 1 gig of RAM, that sort of stuff. And then I think we're going to take a quick look here at the fly.toml file, which has defined a HTTP service and has defined the amount of memory that we're after. And then the only thing that's left for us to run is run the fly deploy command. Actually, first let's take a quick look at the Docker file. And here's where you can see some of the problems. So you can see that this Docker file is basically the same as we found on Google before, so it has the same issues in that it copies everything, including any sensitive files that you might have, or your Git repository, and that it's also using the Flask development server. Nonetheless, we can run fly deploy, and then everything will happen on the Fly service. It'll build your application, and then make it available at sort of a development URL. And then you can send a curl request there, and we will again get the hello world response from our Flask application. So using fly.io is very simple, very quick. There are some drawbacks. The first one is that the Docker file that they generate for you is not production ready. It has the same issues that we were talking about before. And obviously you have to pay them on a usage basis. And it's a proprietary system, so it does what it does. And if you don't like it, then there's not much you can do. Okay, so for the final example, I'm going to show you a tool called Chamcraft. And I'll give you a bit of an introduction to what that is, and also to a tool called Juju. So Chamcraft is basically a way that Canonical has been working to package operational code So application code is where you define the business logic of the application. So your Flask application is sort of the application code where you say, well, I have these endpoints and they should return these things. Operational code is sort of defining how to operate that application. So it knows how to deploy the application, it knows how to integrate it with a database, so get the credentials of a database injected into the application. It knows how to configure your application, it knows how to scale your application, that sort of stuff. So it's all the things that you might do manually in a Helm chart that this operational code that we've written will do for you. And then the tool called Juju is a tool also that Canonical has been developing, which is a way that you can go all the way from sort of bare metal hardware that you might have purchased from Dell to a Kubernetes cluster running. And then you can also deploy applications on top of that. And we've provided a bunch of foundational building blocks, things like Postgres and other databases, ingress, observability, all those sorts of things. And because it's all open source, you can write these things yourself as well as your need arise. Okay, so this is the steps. So Charmcraft also knows. So Charmcraft is how we sort of create charms, and that's what we are calling the operational code artifacts. So Charmcraft also knows how to operate Flask applications natively. And these are the sort of abbreviated steps that it takes to go from just a Flask application to something running in production. In the QR code in the top right, there's again a tutorial that you can follow that in your own time that takes you all the way from a bare Ubuntu installation to your Flask application running on Kubernetes and a production sort of ready environment. And then I'm going to show you a video of what it looks like when you go through an abbreviated version of that tutorial. So in this case, we're also going to make one modification to the Flask application in that it will also make use of a database. So to be able to do that, we need to change the requirements file to also include the binary to interact with Postgres. And then we're going to change the application logic so that the root endpoint just writes a note into the database whenever it gets a visit. And then we're going to add one additional endpoint where you can see how many visitors there were. And you can see here in this database UI, the way that you get the database credentials injected from the tooling that we've provided is as environment variables. So here the Postgres DB connect string. And there you can see what the root endpoint is doing. It's just sort of writing a record to the visitors table. And then the visitors route at the bottom just counts how many records there are in the visitors table and returns that number. Okay, now whenever you interact with a database, you need to create the tables before they're there. So the tooling that we've been working on will run, if you have a migrate.py file or a few other names, will execute that file before it starts the application. And again, you get the same database UI provided in the environment variables and for any other integrations that you need as well. And then because we've changed the application a little bit, we actually need to update the rockcraft.yaml file, and we'll just increment the version in there to be 0.2. And then we need to repack the application with the new code. You can also use a command to actually inspect the full version of the rockcraft. So if you remember before, we were using an extension which hides away some of the detail, but you can also see what that detail is if you're interested. Okay, and then we just run rockcraft pack, which again creates an OCR image that's production ready, that you can deploy anywhere on any Kubernetes cluster that you want. So it's a standalone, useful OCR image that we're going to use to also then deploy using the tooling that I was talking about before. And then we just need to upload the new image again to the microK8s registry. So now we move on to creating the operational code. So we just run the init command, which will put in place the scaffolding that you need for the operational code. So we have done all of that work for you. And then in the charmcraft.yaml file, which defines how your application is going to be deployed, again, you can see that it's making use of the Flask framework extension. And then we just say that the application requires a Postgres database. And you can also see a few other things that we support here. So we support things like MySQL, MongoDB, Redis, observability is there as well, S3 and SAML. You don't see observability here because it just comes by default, but and we're also always adding more things to that. And that's all we have to do. We just run the charmcraft pack command, which sort of takes all of the application logic that we've provided for you and creates a deployable archive similar to a ROC, but this time for the operational code rather than the application code. And then we're ready to start interacting with Juju. So with Juju, we create a sort of model which will contain all the applications that you want to deploy. So that will be the Flask application, it will be the database, and it'll be an ingress in this case. So the first command there is, well, the command that we're working on now, it's just deploying the local charm that you just built onto the Kubernetes cluster. And then you can see that we're deploying a Postgres database for K8s in this case. That's more recommended for development. Juju also supports deploying machine Postgres databases, and they're fully featured with things like replication, backup, that sort of stuff. And then we're also going to integrate the Flask application with Postgres, which is just providing a way for the Postgres and the Flask application to sort of talk to each other and get the database connection string into the container. And then we're going to deploy the ingress as well, and again, configure that a little bit and integrate it with the Flask application so that everything is sort of working nicely. And then we'll just watch Juju for a little bit as it does what it needs to do to deploy all those applications and get them working and talking to each other. And then we can see kind of a final one here where everything is active and idle, and we have established all the relations that we need. And now we're ready to send a request to the root. Well, first to the visitor's endpoint just to demonstrate that it's returning 0. Then we send a request to the root endpoint, and we again get hello world. And then we check that the visitor has been incremented. And if we send another request to the root endpoint, then we get another increment of the number of visitors. Okay, so that is the presentation that I want to show you. So in sort of summary, we started with creating an OCI image for your Flask application. So the tooling that I showed you, called Rockcraft, creates a production-ready image. And then we used Helm charts initially to deploy that container. However, Helm charts requires sort of writing and customizing your own K8s deployment files. So to simplify things, we used a tool called Fly.io, which is a proprietary PaaS application, and the Docker file that they provide is not production ready. And then finally, I showed you a version, some tooling which is simple to use from Canonical, which is open source and creates a production-ready OCI image that you can run anywhere, and then it also provides the operational code to operate your application and also integrate it with database, ingress, observability, and all those things. So if you'd like to learn more about this, we would like to do some user experience research, so you can contact me there on the email address, or you can go to the chat and join that chat and ask us any questions. We also publish updates there for all the new things that we're doing, and it's under active development. We're adding more integrations, so and also more sort of frameworks as well. And here are the 2 tutorials as well that I was showing you before. So yeah, now we have, I think, a bit of time for questions.
So what are the edges for using Rockcraft over Dockerfile?
The advantages?
Yeah, what are the edge cases where I can replace the Dockerfile with Rockcraft?
So wherever you do a Docker file now, you can make use of a Rockcraft file, so it can create applications, any applications that you can think of.
Can it totally replace the Docker file in my environment?
Yeah, it can totally replace it. So anything that you can think of, all the OC images that Canonical creates for the various applications that we have been working on, which includes all the things that you can imagine, like Kubeflow, like databases, like observability. They all have their OCI images created using Rockcraft files. Yeah.
Any more questions, please? Okay, maybe you first.
Just a short one. What version is Juju on, and do you expect many changes? Like, is it still in a pre-1.0 versioning, or?
For Juju or for the other tools as well?
Juju.
Okay. Juju has been around for a long time, for like 5-10 years or something.
Oh.
So we haven't talked about it too much yet, but now we've added quite a few things to it, and we're more happy with it. Everything all the infrastructure that Ubuntu is built on is all deployed using Juju. So things like the Snap Store, where we distribute all of the images for Ubuntu and so on. That's all operated using Juju. So we use it ourselves, and then we also have a bunch of customers who rely on us to operate their data centers, and we use Juju to deploy everything there and to manage them as well.
Cool.
Yeah.
This is the last question, please. Yep.
Does it integrate with AKS and EKS for deployments?
Yeah. So any Kubernetes cluster, you just give Juju the credentials for that Kubernetes cluster, and then you can use it in the same way that I was showing you here. And then the other thing that you can do with Juju is actually go from bare metal, deploy something called metal as a service, where it makes available that bare metal to Juju and to other things. And then you can deploy OpenStack on top of that. And then you can deploy a Kubernetes cluster all using Juju and just commands from the terminal. And so that if you have an on-prem installation, then you can also use this tooling to get to a Kubernetes cluster.
Thank you. And I think that's probably all. Big hands for David, please. Thank you.
Thank you for all the pictures. Very good.